Heads up, we're currently doing some IT testing. The presentation will be live at 6 p.m. So feel free to come back at 6 p.m. to tune in. At the moment, we're just doing some testing. Thank you for your understanding.
All right, Nicola, the recording should have resumed.
Awesome. So you've got the ability to do that. Do you want to just pop that
Yep.
on pause as well? We'll
Yep.
just make sure you can do that.
There we go. So I'm the structural asset manager for ASM. I'm currently employed by WSP, and I've been seconded out to what was the AMA back in 2017 as the structural engineer. And then in the new iteration, when ASM started back in 2019, I became the structural asset manager. Is that me? Okay, so what am I going to talk to you about today? So kind of really I'll talk to you about the ASM, what the structures team do, and then I'm just going to work through probably what's quite an average day working at the ASM for me. So a little bit of forward works, an incident happens, we go out and look at some of those, and then reviews with the capital works projects that we've got going at the moment. So yeah, just a normal day. Really don't seem to be doing well with this. So structure, so what do we look after on the network? So bridges, obviously, tends to be the main thing that we talk about and what we spend a lot of time focused on. But apart from that, we've also got a huge range of other assets, things that might surprise you on there. CCTV masts, again, we actually have quite a few issues with them. Tanks, so the tunnels have got deluge tanks. We actually went up and did an internal inspection of the timber tank on top of Johnston Hill Tunnel last year. Really interesting. We had a little rover in there. We did some hoovering up of the detritus that are built up at the bottom, really quite interesting. And probably a big one that we're focused on at the moment, since there was a bit of a revamp of S7, is geotechnical assets and geotechnical slopes. We had a lot of failures, obviously, over the period of rain back in January, and it's really kind of focused our minds around what we need to do to be proactive in order to prevent those from happening. Just to give you a little bit of, I'm not going to go through every single asset, but just to give you a bit of a context of the network. So this is what we're looking at, 361 bridges, although if you look on one system, it says that. If you look on another system, it says a totally different number altogether. It depends whether you connect substructures together, if you don't. So, but yeah, 361 bridges, including culverts. Gantries, which every time I go out, we seem to find new gantries. So I've put 311, but I think there's more than that. Yeah, a few other things. And again, UDS, I've put 3 here, but we've recently been through a bit of a process of analysing which urban design features that we look after. One that you'll notice straight away is the Pahutakawa flower that sits out on the top of Nelson Street, so we look after that. But there's also a real interesting range, some of them visible, some of them not on the network. They don't take up a huge amount of our time, but we've recently been through a process of identifying them all so that we can take care of them properly and give them the proper respect that they deserve. It is interesting. We have a lot of problems with capital works on who owns what, who looks after which section. Is the sign belonging to the ASM, but even though it sits within a certain area? So you'd be surprised about how many weird concepts we get. So this is the network that we currently look after. It's been ever changing. There's been iterations of it, and we've had new sections. At the moment, we look after SH1 right down to Rangariri, which obviously is within the Waikato region, but it now sits with the ASM. It makes a lot of sense in terms of the traffic volumes on that section of the network. SH2 is also a new section that we look after, which previously probably quite different to the rest of our network, and there are potential changes in the future, but I won't focus on them too much. Yeah, so some of the big projects we've got, I'm going to talk about soon, are the Grafton and Newton joint replacements. We've just finished doing our TOC 4 pricing, so we've priced up every job that we think we're going to have from 2024 to 2027. I remember the previous lead out at Wakakotai for structures would always say to me, don't price anything 2 years in advance. You're never going to do it. It's going to be a totally different project. But we did it anyway. I've been through that process. Just kind of a list of the capital work schemes on here. Quite a few have been involved in those. So we've got Peter Liskins here from Omaharangi Pen Link. So that's been taking up quite a bit of our time. And obviously I know they've started a lot of groundwork now, because as I travel up that East Coast Bays Road, it takes me a hell of a long time because all the work's going on. But so that's going well. Peter D, we're doing a lot of works at the moment in terms of reviews. Handover of bridges was requested relatively recently. So lots of projects going on. Yeah, and I'm going to talk to you about some of the issues we've had on some of the other ones. Okay, This is my team. So there's myself, there's Alex, my engineer, who's in the room today. And then I've got a really great inspection team, which is Gareth Duggan, who's, I'd say, one of the best kind of national inspectors and has done a lot of the audits for the other offices as well. And then we've got Sebash, who's from HEB. We've got David from WSP and James Sedlock, who's a recent person that's been added to it. But I've also put up here, because I think the big difference between the alliance arrangement compared to a lot of the SMC contracts and the NOCs is that we work really hand in hand with our delivery team. So both Hayden and Gordon, I sit with and we talk on a regular basis. If there's an issue, Gordon's out there with me. I was out with him last night trying to fix a hole in a bridge deck that we found on the SCI project. So yeah, that's our team. Yeah, I joined WSP back in 2017, and I've been kind of embedded in the AMA and the ASM the whole time. And it's been very different to sitting in a design office. And it's, I always say to people, I think the best thing about my job is I sit down and then 10 minutes later I get up and I go home, because it's been 10 hours and you just don't realize it because it's just thick and fast the whole time. So yeah, forward works and inspection. So this is probably what you would think of as the main part of our job, but I kind of, as you'll see, there's a lot more to it. Forward works and inspection. So to me, the inspection process is really what drives everything. We gain all of the asset information, understand what's going on, and then we kind of go through a process of defect identification, developing a maintenance action plan, putting together a TOC, doing SAPA forms that we submit over to Waka Kotahi. They approve it. Then we have to go through a TOC process and get the financing for it. And it can all be very difficult sometimes to try and get everything to align, and then all of a sudden something will happen and change things. But in terms of the inspections, fairly straightforward. I think, interestingly, compared to other areas of the networks, we haven't got a huge amount of inspections. You'd probably look at that as an SMC and go, 750 inspections in a year, that's actually not that many. You could probably get it done in a couple of months. But because of the way that our network is arranged and the fact that the vast majority of our inspections are done at night in closures, means that it takes us a lot longer to undertake it. So one bridge could end up being 4 different closures. You could have a northbound, a southbound, some on-ramps, the local road over the top. And in order to actually do an effective PI, that's what's required. And I think one thing that's really important, and I'd say to people who do have principal inspections undertaken, is, especially on our section of the network where it's so busy, is that it's amazing how many problems are created. If something's going to happen, it's going to happen in Auckland. As soon as I think to myself, oh, but that probably won't happen, that's exactly when it does happen. And I'll show you an example of that coming up soon. Another thing, because of the amount of gantries and bridge assets that we actually have our own EWP. So it's a ute mounted EWP. And I think, to me, that's probably the best purchase that the ASM have made, or it was actually HEB have made, since I became the asset manager, because it's just meant that we've been able to keep the network open and keep the cars flowing as quickly as possible on the network and reduce the amount of closures we've had and the time. So yeah, just going to talk a bit about forward work. So split into lots of different categories. We've got our 114 works, which is all our concrete repairs, investigations and assessment work. We've got our 215, which is all of our major component replacements. 216, we've actually got a replacement of strand rail structure. In theory is supposed to happen at the start of TOC 5, which will be July 2027, but the design work's going to be taking place over the next 3 years. Well, it shouldn't take that long. And then obviously strengthening and replacement based on level of service, and then low cost, low risk. The project that just indicated here at the bottom was just recently completed. It was part of the low cost, low risk type funding arrangement. And this is installation of throw screens on on Killington Crescent footbridge out towards the motorway, out towards the airport. So yeah, pretty standard stuff that kind of all goes through. So forward work. So a couple of the big ones this year are joint replacements. I think one thing that I would say is that my son says to me, why do you just spend all your time talking about expansion joints? Every day it just seems to be expansion joints. And I'm like, yeah, unfortunately they cause me a lot of problems. And when it comes to capital works, it's not the main thing that they're focused on. Often they get to the end and they go, oh, and we'll put some joints in, and they put a little square on the drawing and say joints, and you're like, yeah, that's the one. But it takes up a huge amount of our maintenance time. So Grafton Bridge and Newton Bridge, the problem with both of these is both of the joints, if you look on the drawings, they're 75 mil. That's the size they're supposed to be. We've been out and measured them. They're 100, 110 mil. things are never quite constructed as they're shown on the drawings. Because of the width that they're at, we think that we're having the amount of failures on them that we are. So we're looking at replacing what are currently nosing joints with spanning joints. Originally, when we priced it, we had loads of problems, so we were just going to do a standard replacement. And then because of the, when we went out and did the investigation works, we saw it was larger, and so the costs massively increased because we're looking at installing like a tooth and comb type joint, the Mara XC1. So just to give you a bit of an indication of some of the problems that we face on doing these kind of replacements, because we've got a really set process for replacing joints where it's just nosing to nosing, quite easy. We'll go in, dig it all out, and we use, the vast majority of the time, we're using like an Mcrete M-Seal, which is an elastomeric type concrete, which we seem to find is fairly robust on our network when we're in areas of 110,000 AADT vehicles traveling over them per day. Those seem to be fairly robust, whereas we see, I mean, the fairly standard ones like a Wabberflex joint or mechanical fixed ones, they seem to break out within 10 years, and we're doing a lot of replacement work and a lot of refixing the mechanical details. So that's why at the moment we're favouring an elastomeric type concrete where possible. But for this one, it's not viable, and so we're looking at doing a replacement to a Mara XC1. This bridge right in the middle of the CMJ, you could probably see it from here, I guess. It's just over that way. And it's, yeah, really busy part of the network. And so we looked at how could we possibly construct this without causing Auckland to come to a standstill. And for us, the only possible period of time that we can do this is over Christmas. So we've sat down with our journey optimization team and looked at all the traffic volumes and said, there is no other time we can do this other than Christmas, and it's going to be in continuous 24-hour cycles of working where we'll be out there on the network, digging up and replacing and putting different sections in, and we've had to go through lots of different iterations, and there'll be points during Christmas where we'll be down to 2 lanes on that section of network all through the day. And but we are predicting only like a maximum of a 20-minute tailback, and we've had lots of conversations with ATOC and all of the other people who've invested in it, all of the different like Spark Arena and everything going on to make sure we don't cause too many problems. So yeah, so it's a busy one. So just kind of, we've gone through a whole detailed plan of what's going to happen each day, and we built in contingency upon contingency upon contingency. And you know that the first thing that we'll get as soon as we're out on the network is people posting on Facebook saying, why on earth are you doing this now? What a ridiculous time to do it. But it literally is the only time that we can, where we're going to cause as little disruption to traffic as possible. I think we've managed to convince ourselves we're going to get down to about 2,800 vehicles per hour at peak, which with 2 lanes of traffic open, we think is not going to cause too much of a tailback. So we're very hopeful. But yeah, we've been through a lot of process, a lot of agreements, and I think that's kind of the process that we have to go through, is making sure that everybody's happy, because as soon as you don't, and you don't think about something, you don't get someone involved, it just causes you a lot of problems. Very similar one, Newton joint, and this one here is the one where I think of, if it's going to happen, it'll happen in Auckland. So the this joint here, it just had a seal in the middle of it that fell out, and we went and looked, and somebody identified it in an inspection, and I think we said we'll go out and replace it in the next closure, which was the Sunday night, and it's about 4 days away. And someone said, oh, do we think that a cyclist will fall down it during that period of time? Because it's a fairly well trafficked route. And we looked at it and we said, well, if you're traveling along as a cyclist on the road, you're quite far away from it. If you're traveling along on the cycle path, you're quite far away from it. It's in between the two. So it should be unlikely in the next 4 days. And within that 4 days, we had a complaint come through. Somebody's wheel had gone right down through the joint, down to the forks, and they'd come over the handlebars. So it's again focused my mind that if it's going to happen, it'll happen. So let's just do it as quickly as possible. So yeah, I won't dwell on the detail, but again, it's another one where difficult to install, a lot of pulling out, and it's going to take us a long time to install it. So it's going to be over the Easter weekend or possibly next Christmas if we can't get it done. Another one, some of you might recognize this one. So Hillcrest Underpass had a lot of problems with coating failure. It used to be a beautifully bright red piered bridge, and it faded incredibly quickly. I'm lucky enough to work with Rayad El Saraf, who's a coating specialist, and we've had long conversations about what we need to do here. And we had a lot, I think this one in the end was pushed from up quite high in Waka Kotahi, where somebody travelling under it said, "This is awful, let's get it sorted." And so luckily we managed to push this one through, and it was the right decision, because when we actually started taking the paintwork off it, there was a lot of failure, a lot of areas of high build that were put underneath it, and we were really glad to get this replaced and prevent that corrosion from taking hold. One thing that I kind of just want to point out, if you are involved in doing any recoatings, really keen to make sure that contractors and subcontractors are PCCP accredited. We built it into the contract for this project to make sure that everybody that was doing it would be, and it is a requirement for Waka Kotahi, so really keen for that to be reiterated. And we managed to make sure that the supplier went through the process and had the required paperwork for this one, so it was really good. So we're glad to get it sorted. Again, this one was done. Difficult location. We managed to get steel barriers put in place so that the guys could work from a 42-meter EWP to undertake the work. So I went up in it. It was quite scary, even when the wind wasn't blowing. And yeah, it was a great project. So this is kind of what it looked like before. You can see it had gone to almost, it was grey in some areas, lots of flaking, lots of breakup. We've got matte cracking all over it. There was lots of differential temperature changes because when the sun came around on the one side, it got hot. And so it went from what was a beautiful red colour, and now it's back to this again. Now, if anybody's been up there, they might notice that there's something not right about this picture. And that is that as soon as we'd finished it, the graffiti artist came and did a great job of covering that beautiful white pier foundation in graffiti. So I've actually photoshopped this one just to make it look nice, but no, it really had graffiti on it. And Pork has done, he's a very brave person, Pork, and they hung over that banister and graffitied on the outside of it with no support, just one hand on the barrier and one hand, and then their feet on the concrete, and spray painted it. So very brave people, but yeah, it was a good one. So now I'm going to change hats. So that was kind of what I do in the office and my normal day job, but I'm just going to quickly change into my other persona. And that is one of site person. And we have a lot of incidents on the network. And it's whenever I have a day where I've got no meetings planned whatsoever, and I go, I'm going to have all day to get everything done, so it's going to be great. That's the day when we have massive strikes. So I'm going to change now into my site persona. And there's one thing that you'll know every structural engineer needs when they get on site. That's a good hammer. And I actually brought this one with me from the UK because it's my favorite one. Last night when I went out onto site, I've got a delivery foreman. As I walked up, he went, "Oh, here comes Dave with his golden hammer to fix everything." So that was good. And also, I was chatting with James Arman from Waka Kotahi today, and he said, "Oh, you're going to talk about the hammer?" I was like, "Oh, yeah." And he went, "Well, do you remember that hammer almost got you kicked off of the Papakura to Drury site? Because I went there and started hammer testing some concrete, and everybody started panicking and said, you can't come back on site with that hammer. So I'm not allowed to take this onto the Papakura to Drury site at the moment, but there we go." Yeah. So let's move on. Incidents. So we have a lot of incidents. So we've gone to the step now of putting in place an incident plan. We've developed a different set of levels for it. We have a duty engineer constantly in place on the network because we get incidents all throughout the night. And so we got to the point where we said the risk level is too high. So there is a direct number for everyone to call, and it reaches either me or one of the other duty engineers, or Gareth, and we'll go out to site to see whatever issues are going on. But this is the process that we go through. We were getting calls for the wrong things, and then we weren't getting calls for some of the stuff that we really wanted to go to. So we've had to go through a bit of a training process. We created a bit of a cheat sheet for our staff to go, and every single one of these pictures are incidents that we've attended within the last year. So last year, maybe the last 2 years. So Princess Street, getting an overheight strike where we had to go out and replace that flange. This is up on this is where a contractor dug a hole through one of our underpasses. They were excavating the wire rope posts, and they neglected to see there was a bridge there, and so they dug a hole through the bridge. So Penrose Bridge. So lots of the Hill Road where they drove through the barrier. So yeah, all incidents. But we kind of gave them an idea of what the different levels are, when we need to be called, when we don't. Penrose. So if any of you know the Auckland network, the lowest one on the network, how are we doing for time? Good, okay. The Penrose is the lowest one on the network. It is 4.47 meters high. The bridge says on it 4.57 meters, and the bridge manual actually demands that we don't need a sign on there at all because it's above 4.3, so there's no way that anyone's going to hit it. Yet we have multiple strikes every week. We've had 2 in one day at some points. And so, yeah, so I end up visiting this bridge quite often. It's It's fun. So this is the bridge. It looks fairly innocuous on this picture. And here we go. So this is the bridge as it stands at the moment. We've got an overheight detection system that as soon as a vehicle goes over there that's over, we've slightly changed it recently, but over 4.45, that sign goes off. Stop, please don't go any further. There's a big pullover bay. We've got a big collision protection beam in there that's saved that bridge quite a few times. We've just put on, there's lots of TikToks about it. You can see Facebook posts about it, and yet we still get plenty of hits. So this is one of the recent ones that we had back in, I think this is the one back in May or August. So that you can see this is us on site with the UWP that I pointed to. And we were out there, there was a bridge strike. This is the level of damage that we had, deformed reinforcement, huge amount of loss of concrete. That incident happened, we were out there within 30 minutes. We were up there, we removed all the loose concrete and we were off. And whilst we were there, we had one lane for a period and then we went to two. I think we were off within an hour. We caused a good hour tailback. And when people came past, they like to shout and abuse us and say, what on earth are you doing this now? And it's like, okay, thanks. So it's not appreciated, but yeah, this is the one. This is Gareth up there pulling the concrete off at the time. We knew it was quite a big one, so I went and took some pictures as well. But you can see that, I mean, if you look at the bridge, you can see we've got multiple areas of concrete removal, and you can see all of the banding and straps. At one point in time, this structure had armor plating underneath it. We pulled it all off, and when we found that, the condition was absolutely terrible. We had to do a huge amount of repairs. We were repairing, I think, like 200 mil sections at one point, so that the bridge could retain capacity. Otherwise, it would have been terrible because of the loss of concrete from the strikes. So it's that strange position where you want the armor plating there to protect it, but it was just covering up all the damage that was getting caused. And we actually had a bridge at some points where I don't think we fully understood what the condition was. So now at least we can see the condition, but then it gets worse strikes. So we'll keep going at it though. Yeah, so I mean, and this is it. And we put this happened about 11 o'clock in the morning, and we had that beam fully recast by 2 o'clock the next morning, and then we pulled all the props off it by 6 o'clock in the morning. So it was a great repair, great effort by the team, and just kind of shows you some of the capabilities that our structures team have now developed because of how much we've had to deal with. Basically, it's absolutely fabulous to see. I'm out there saying this is what we need to do, and then I've got a team of guys there creating the formwork and putting it in place in like a couple of hours, and it's really impressive. So yeah, picture of some of the team undertaking the works. This is Jan. She's holding the spanner that we use to check the nuts on the collision protection beam. Every time it gets hit, the nuts kind of spin and we have to go out and retighten them. Some of the impacts on that beam have been so significant, they've actually caused the piers to spool out. So we had about a 400 mil high section of broken out concrete where just from the collision, didn't touch it, but it just, because it put so much of a shock through the beam, it caused the piers to spool, which was fascinating. So this is that final repair, and that was done by that night, and then we had it reopened to all traffic within 48 hours from it casting. So it was a good one. And I just wanted to kind of point to the level of detail that we go through. So we've got a journey optimization team that could look at all of the traffic volumes, and we were trying to make a decision as to when do we start the closure and when do we end the closure? Can we have 2 lanes, or what can we do? And they actually worked out that if we started it earlier, we'd cause huge, they kind of look at me and go, what time do you want to start? And I say, well, can we get in for 9? And they go, no, you can't. That's like, you're going to cause chaos. And I go, okay. Can I keep the road closed until 7 a.m.? No, you're going to cause chaos. So it's that kind of trying to balance between the two. And it was like, how long is it going to take us to do the repair? But it was really interesting to sit with them. And now they've got a system whereby I can test these theories really quickly and go, what about 2 lanes? What about 1 lane? And they went through the process. It was good. So we had closed from 10 o'clock at night, and then we had 2 lanes from 4 in the morning, 2 lanes closed from 4 in the morning, and then it was fully open by 6. And the tailback was pretty minimal. So it was good. Bremner, I'm only going to quickly touch on this one. A terrible incident, and it was a blowout from a tyre, we believe, where the driver was impacted right into the pier in a fully laden truck. And yeah, we were out there during the incident whilst the police were still there undertaking their investigation. The vehicle had got pinned on the barrier, so it actually had to get craned out. I think it was a really interesting one, just because of the amount of closure we had to put into place. So it was a very odd situation where I was on site with Gordon and we were waiting for everything to get cleared. And we went back to the the BP station just up the road, and it felt like it was a beautiful sunny day. It felt like there was nobody around. There was absolutely zero traffic because we closed the motorway over, we closed the local road over the top of it as well. And then I was phoned back into the office and I'd said, "Oh, how's the network looking?" And they're like, "It's chaos everywhere. Just get it open as soon as possible." So it was an interesting one, but just to give you an indication of kind of the damage that was caused, the guardrail didn't cause it to deflect it. It directed the vehicle straight into the pier. Unfortunately, in this situation, cracked straight through the pier. Caused we didn't think it caused any cracking at the top, so I used the EWP to get up there and check it so we could reopen the road underneath as quickly as possible. You can just see there the amount of material that had spalled out right down to the internal reinforcement. This was the structure itself, and we had a bit of a scan of what was really nice was the police got involved with us and passed us the scan so we could see what the level of issues were, the survey detail. And you can see that always fascinating to see how it was constructed compared to what the as-built showed. So when I came up with a bit of a design and drew it out on site, drew it out prior to going to site to decide what we wanted to do. Then when we excavated down to the foundation, you can see that the pier wasn't aligned with the foundation at all. It was right over to the one side. And we also had segregated concrete at the base of the pier column. And it wasn't just the fact that it wasn't the strike that had caused it. It was segregated anyway. So I had to do a bit of redesign whilst I was on site in my orange top, and to get it sorted. But it was good in the end. It went really well. We just constructed basically a collar around it, and this bridge is getting demolished within the next 3 years. So in terms of structural capacity, I wasn't concerned with it. I think if we'd known it was going to be in situ for a lot longer and we need to keep it in service, then I think we'd have undertaken a bit more repair work on it and it would have kept the closure in for longer. But in this case, we did a collar around it so that future impacts would have less impact on the actual pier itself. So it was a good one. And then I'm just going to quickly talk about some other incidents that we kind of get. So fires. So we have a lot of rough sleepers out in this area. And in theory, we've had some people that have lived under structures for 10 years and they don't cause us any problems, apart from the fact that we get a lot of buildup of material. And when other people come in, they like to set fires and cause us problems. So this was a recent one under Bereford Street Viaduct. I met with some of the rough sleepers that have been there for a long time and they were really upset because they'd actually lost all of their belongings, which was a really sad situation. And we're trying to see what we can do in terms of integrating with them a bit better in City Mission to understand how we can improve the situation. Causes a bit of spalling, bit of damage, but we were quite lucky in this system. The only problem we really had was that the whole entire drainage system had got melted, so we need to go out and replace that as part of our future works. EV car fires, we're starting to see a lot more of them. They're becoming a lot more prevalent. That was a Tesla that set on fire as they were driving, and they decided to get out when they were on top of Auckland Harbour Bridge. Luckily, the lithium battery didn't set on fire on that situation, and it was on the concrete section, and it wasn't on the steel clip-ons. But it is something that is becoming more prevalent, and I think we need to be able to deal with those situations. And I don't know why, but we often get people that park under bridges when their car sets on fire. It's like, they're like, it's on fire, I'll park under this bridge. So I've attended quite a few, and you can see this footbridge is pretty slender, and they've decided that that's exactly where they're going to park at the time. So, and again, that was a hybrid vehicle fire as well. So becoming a lot more of an issue, needs to be considered as part of your works. Barrier strikes, we get lots. I won't harp on about it. We've actually built up a bit of a stock of posts and details now so that we can replace them as quickly as possible. And this is probably an interesting one. Somebody mentioned it earlier in terms of vehicle rollover and how we kind of think about it. So this happened down at Cavendish. And the really interesting thing about this is the vehicle's full of glue, of adhesive, and it started to pour out. Not a problem for the network particularly, but it went into the drainage system and there was pictures of the pond, and the glue had all started to pour into the pond. So just thinking about how you deal with it. We got out there and blocked off all of the gully system so it didn't go any further, but it was just a bit of an issue. But in terms of rollover, there's a 400 mil gap between the pier column itself and the barrier system. And it still managed to hit it. It wasn't too problematic, this one, because as it overturned, the speed had slowed down quite significantly. He just overshot the off-ramp coming downhill, decided to go through a traffic light when he should have just stopped, and unfortunately overturned. And just the damage was minimal, but it was just an interesting one. And then obviously recently we've had a lot of flooding issues, and this is just Hillcrest drainage culvert. This was a bad situation where we had high tide at the same time as all of the water came down through the system. So this is just north of Harbour Bridge at Akaranga bus station. And we're just kind of looking now at how do we improve the situation. There's a few little things that we're going to do, but really the answer to this is we need to build a new bridge. So if anybody's got $15 million+ available to build a new bridge, let me know. We'll put one in here, and we won't have this closure in future when it floods. And then some of the other, I get a lot of complaints. I have some really fascinating documents that people produced explain to me why my bridge is failing, that I have to respond to, which is really interesting, and it's good that people are testing me. This was an interesting one whereby I was told the water coming, this was during the floods back in January, they were told me that the water pouring off of the embankment had caused the pier to rotate. And they told me that in the middle of the night. So we went out in the middle of the night to look at it, and I couldn't see anything. I got told it had happened again. Then people were looking on a camera, which has got like a bit of a fisheye lens to it, and they're like, it's definitely rotated. I was on the phone with my manager, Ben, and we were looking at it. We're like, how is it rotated? It doesn't make any sense. I finally went out in a boat to look at it, and there was a bit of a collapse of retaining wall, but it wasn't rotated. It was just, a bit of a curve on the lens. And then lots of collapses. Interesting. Great. Capital Works. I'm probably just going to, how long have we got left? 1 minute. Cool. Capital Works. SCI had lots of problems with their joints, caused lots of failures. We're currently doing a lot of replacement works in terms of QA and overview on site. It's great to get out there and keep our eye on it and make sure we check it so that things doesn't happen. A lot of these were done during COVID, so we weren't able to be there, but it was done. And then some gantries we've had handed over to us. They've said I've gone in and looked at them, and when they were stood there, there's lots of internal corrosion on the welds. You find that was a piece of detritus that I pulled out of it whilst it was sat there, full of water. And then when I got the handover documentation, they said, "Yeah, closed." And I said, "Well, how did you fix the internal corrosion?" It was like, closed. So that's some of the problems that we face and we have to deal with. But yeah, there we go. That was it. Thank you very much.
Thanks for that masterclass and the national network. And now it's in the Auckland context. Now it's time for we'll keep questions to the end. Now we'll look at the local Auckland network with Gang and Cam. So Gang, I think you'll start off, or Cam, even better.
Well, good evening, everyone. Thank you very much for the opportunity to come and speak to you this evening. I'm going to do the easy part, and then I'm going to hand over to Gang, and Gang's going to do the heavy lifting this evening. So that's well done on my part, I think. So we're going to have a little bit of a chat to you this evening around the performance of the Auckland bridges. But to kick off with, I'm going to talk to you, we'll break it down into a little bit about AT, just to give you a bit of an intro into AT, what we've got on, a little bit like what Dave provided around ASM. That's the easy part. I've got that. And then Gang's going to get into the tough part around the floods, the cyclones, and some impacts to a bridge or two. And for those of you in the audience who are members of AT or former members of AT, just nod knowingly. So just to sort of set the scene around AT, the purpose of AT is to contribute to an effective and efficient and safe Auckland land transport system in the public interest. And we've got a couple of operating principles to remain fiscally or financially responsible, prudently manage our assets and liabilities, remain viable, and provide a successful ongoing concern, and to use revenue efficiently. And although it's not a bridge, so you're probably not really that interested, everybody likes a little bit of disaster porn. So I thought we'd show one of the great slips from the January event. That's up on the Manukau Heads. So Manukau Heads Road, circa 100,000 cubes moved in that piece. Okay, moving right along in terms of the infrastructure types that AT looks after. We've got about 40 odd railway stations, 23 odd ferry terminals, 16 bus stations, 7,500 k's of road, mixture of a bit of cycleway thrown in, 10 multi-storey car parks, 250 at-grade car parks, couple of airfields, 72, soon to be 93 odd trains, 760 odd bridges, stormwater channel, circa 4,500 retaining walls, and a lot of other stuff. And the other stuff includes things like the traffic lights, street lighting, and there's a whole lot of wayfinding and other sorts of assets. So there's quite a diverse range of assets under management by AT. In terms of the structures asset management piece, the total portfolio sits currently at around about 26 billion. We depreciate at around about 450 million per year, or around about 1.2 million per day. Within that breakdown, you can see that the largest asset category by far is in the roading space at around about 12 billion. But the structures, the bridges, walls, and gantries come in at 2.8 billion. In terms of where Gang and I sit in the overall structure of AT, we sit in the Integrated Networks division, excuse me, reporting to the head of asset management. And within that, we're broken down into 3 core streams: policy and planning, networks, structures, and metro. Within the structures and metro team, we're responsible for bridging structures plus all the PT components. So that's back to the ferries, airfields, trains, wharves, car parking buildings, etc. So we've got a reasonable amount of responsibility, and that's currently being delivered by a team of 5 or 6, supported by asset management consultancies, currently WSP and Becker. So that's really a very quick and dirty high-level overview of AT, but I thought it was important that we sort of set the scene. It gives people a bit of a flavour. It's not all about my bus not being on time or my train running late or something like that. There's quite a bit of other stuff going on. That's the controversial part. Quite a bit of other stuff going on throughout the network at all the time that we're trying to manage and juggle. So that's my part. That's the easy bit. I'm going to hand over to Gang. Gang's got the tough piece. He's going to talk to you a little bit about the outcome of some of our experiences during the cyclone and floods from Anniversary Weekend and Cyclone Gabrielle.
Cool. Thank you, everyone. Thanks, Cam and Dave gave those information. Hopefully you have been overwhelmed, so you can ignore my presentation after. Yeah, so to make online people jealous, we have very nice and short refreshment before the event. Why I say that's nice? Because I have been very busy to go around comments. Half of the people don't cast hard question on me. Why we say it's short? You probably already get the answer, because we still have another half. They probably give me hard question. Yeah. So before I make a start, I have a upfront statement. I've got myself drunk, so I don't take liability on what I'm gonna say next. Yeah, but after those jokes, how many minutes are left? Oh God, I still have to talk through. Yeah, yeah, Gang here, principal asset engineer on transport structures. I got structure background and expanded it to asset management in the past 4 years with Auckland Transport. Yeah, it's kind of like a high risk area, so on structures. So you can imagine if you manage those network structures, what can make you feel safe and sleep well at night by put some safety measurement or counterparty risk management. This is something we normally don't expect for in normal operation. Especially this year, you know that if you're under shipping and workload increased because of that. So that put a lot of additional workload on everyone. Yeah, Cyclone Gabrielle. Yeah, so when that happened, so this is the first time we have such a massive natural disaster. Yeah. What we have done, we have followed the national good practice or policy to say that seems for people you don't know, you can maybe spend a little time, have a look, because that's open and free information to everyone. So that's the very high level of protocol we follow from Auckland Transport to deal with natural disasters. So follow that, we set up the MT office, that's incident management, IMT office, that's the incident management team. So at the first step, immediately after the event. So reactively to manage the urgent demand from the network, make site safe as the first place before we repair that. So now we have moved on to the second one. That's the transition from IMT to recovery team. So we are in the recovery stage. That has been run for really a couple of months. But we expect for that could run for another 1 or 2 years, depends on how much work left. It's kind of like a very long tail effect. Flood can come and go very fast, but work will be a damaged structure, road network will take time to recover to the level it's supposed to be. And if you want to follow up the progress, probably you can look at LinkedIn, Auckland Transport official account. So progressively, we will release the information and make that available to everyone on the progress. Cool. Back to the recovery team. So bottom left side, there's two recovery scope. One is the collect the concerns and share information of recovery progress and network disruptions. And second will be identify damages and restoring damaged assets and services back to normal. Oh, next one, yeah. Come back to the bridge team. So that's the and the CAM but we have a very small team and come to the bridge and covers just CAM and myself to carry out the asset management. And I give you the big picture from top left corner. You can see that's how the bridges distribute across the whole Auckland region. And I particularly love that dolphin. Hope you like that as well, because that's genius from my colleague Mike. When Mike is our asset information team, when they draw the boundary of different contract area, yeah, it might be good to add some fun to our day-to-day life, because every day we have to deal with a lot of hard questions. That's the reason I hope that I don't collect a lot of hard questions tonight. Yeah. After the event, we carry out the inspection of nearly all the bridges. But the Auckland region is divided into 4 big sub-areas. So north, west, central, and south. Central and south managed by Becker team, and north and west managed by WSP. That's our 2 contractor, help us to deliver the wonderful job. They did a great job, actually. So we collected the post-flood inspection, emergency inspection, and I put all come together and try to identify the keyword populated very with highest frequency. So those 3 are the ones. So one is debris, another is a scour, and the third one is erosion. Yeah. If you look at the open resource and look at the bridge failure across the world, you will see that the water failure is the most significant one among all the disasters. So that scour protection is really a big task. And so this time, then this flood event just make that even bigger for us. Some locations, some bridge sites, we didn't identify the scour risk. This time popped up. And that's kind of like a massive portfolio to manage. You can see a full picture from right side. On the top, that's the abutment scale damage. And in the middle, that's the debris, very heavy debris of the sand. Sand move and fill up the bridge span and change the water flow and push that away from the original channel, move more onto the private property. So private property owner run Auckland Transport say, okay, you guys need to take some action to avoid my property got damaged because the water stream changed its way to run. And the bottom one, the reason I populate this one is not only because of the scour damage, but also you can see the big pipe. So just to tell you that Auckland Transport Bridge got very heavy interface with other utility operators. So we got services attachment from water care, from telecommunication attachment from cores, or water attachment from council and wastewater and clean water, whole lot of things, and other local electrical operator as well. And some bridges, like one of the bridges called Inga Bridge, so it's newly posted. That bridge got everything. So even gas pipe attached onto the bridge. So, yeah, along with the live wire. I don't know why, but that's quite a high risk to combine those together. To deal with those, we collect all the information, we process data, extract the key information, and say which specific bridge should win more priority among others, and we come up with the program. So we developed the two programs as all come of the emergency inspection. The first is the debris cleaning program. Debris cleaning, you can think about that. Sounds quite easy, but when you come to the bridge, you will need to think about quite a deep approach, and sometimes in the water, sometimes you need to across the boundary, not only Auckland Transport Road Reserve, but you need to encroach into the private owner's property as well. And a lot of things you want to touch and damage not only so the debris didn't damage the bridge, but sometimes they damage the water pipe. You will need to manage the interface with others. So that all of those come together and create the complexity of the debris cleaning as well. We need to make sure we clean the debris, but we don't cause the secondary damage to other facilities or other services attached to the bridge. And that access to the bridge underneath is kind of a very, very big challenge that costs quite a lot of money. And very specific, you don't have a golden plate to apply to all the bridges. Each one got a very unique situation. So sometimes it's so hard for the heavy machine to go down to the deep, and you will need to think about how to carry out the cleaning very smartly. So if you remember the previous one, in the picture in the middle, so that's a sand dune accumulated from the first span. So ultimately, we use the air blaster to clean that slowly, because it's very soft water bed underneath. It's so hard to send the machinery around, and you don't expect for the labor digging, right? Because it's in New Zealand or in China. So your cost will blow the roof. That's debris cleaning program. Also, we have a scalp protection program. That's a little bit more structure involvement compared with debris cleaning. It's not very straightforward. You will not consider not only the access to the site, you will need to consider the source of the material and the size of the scope protection, and what kind of level you want to bring that up to, and what kind of water level and water flow speed to cope with. For that, we wrap up a program and engage a specific team to work with consultant, help us to come up with some specific solution. Here, I will not read out the detailed numbers, but you will get this information after the event reading. You can have a look. That's the total number populated. The big trend from those charts is that you can say most of the projects and the problem come from north and west. Because of the topo, that's most problematic area under such kind of extreme weather. Yeah, that's probably the reason initially when Jonah engaged us, can you please talk about north and west? Yeah, I think, probably that's kind of like a representative to the whole network problem, because in the central and source, we don't have very significant site to worry about a field, but not as significant as those in north and west. Yeah, I just give you a specific case. So this is the worst one. We lost the Milflet #1 bridge. That's a quite old bridge. That's a posted bridge. Posted bridge means that we have weight restriction on this bridge in the past. The reason we haven't been bothered to update this bridge up to current level is that it's bridge in very rural area and serve the very local area. So we didn't see the justification from the traffic demand to bring that up to the level. But this time, the flood did job for us to remove the bridge. So yeah, probably we can hopefully save a little bit money from demolitions. Yeah. Lucky we didn't got we didn't got the report about the no people got damaged from this incident. That's great. So what we have done after this, we have immediately contacted Wakakatahi because Wakakatahi managed the Bailey Bridge service. We set up the Bailey Bridge on site just to recover the local community transportation demand quickly. The Bailey Bridge was set up to kind of like a class 1, no problem. But we leave the weight restriction on site. The reason is that we sit the Bailey Bridge behind the abutment on the ground. We don't have a full confidence on the ground situation, so conservatively we leave the restriction over there. The new bridge design, the permanent bridge, is on the way. So I hopefully to deliver that as soon as possible to capture all the demand around. If you ask us, will that bridge be submerged again from next event? Definitely will. The reason, you probably need to think of why we didn't lift the bridge to the level is it will not be submerged. Yeah, just give you a second to think about it. If you are in this position, why it's not lifted. You can think of like from the network level, all the bridge is a node to the whole network. It's connected from approaching roads. It's confined by the topo locally. This bridge got the connection from both ends, and if we just lifted the bridge, that's gonna initiate a kind of like a very, very big project. You will need to lift the approaching road as well. But does that really make sense? You will need to look at the level of the residential around. So if you lifted the bridge, you lifted the road, okay, or the residential got submerged, you just get island. You can look, but you can't approach. So that's your cost and benefit doesn't really match. You can't really leave the bridge as an island under the flood event. It doesn't really make sense and useless. What we're going to do is that we have a good discussion with our supplier that's from Road Lab, and we say we design that bridge to be submerged in the major event, but we will design that for the lateral loading scenario. Make sure the bridge will not collapse, and when the water go away, the bridge is still in good condition to take the loading. Yeah, so that's a bit story on the Milflet #1 bridge. You can, if you are interested, you can search website. There is a video shared by some people around when the bridge was washed away. That's kind of like you can see the power of nature. Yeah, I'm approaching the end of my presentation, so take it easy. This is the last page. What we talk here is frequently submerged cluster. So we found a couple of bridges has been submerged very frequently. But similar to what we talked about on the Milflet #1 bridge, it's sometimes it's not because Auckland Transport don't want to invest to lift that. It's subject to the restriction from the environment. We don't make the bridge as an island in the flood event because that's useless, and all the investment money come from everyone. We try to use it smartly. Yeah, so those pictures are all from those field bridges. What we're gonna do on those frequently submerged bridges, we have a kind of like a in place protocol, or say lessons learned, or we are prepared for next event. Hopefully that will not come, but if they come, what we're gonna do, we're gonna inspect immediately after the extreme weather, just to make sure that structure is still the structure integrity is still guaranteed. And also interact with the heavy vehicle permitting team. We have the team in Auckland Transport to look after the heavy vehicle route across the whole network. That's what we have done in the after the January event. We talk to the heavy vehicle team frequently. Yeah, every couple of days. So, okay, this bridge inspected is in good condition, and this bridge is got some problem. Try to direct the heavy vehicle away from that route. So such kind of communication is kind of like a collaboration with the wider team. Just make sure that the structure provides safe service to the traffic. Also, we have some short-term and long-term solution. Short-term is that we need to remove the debris as soon as possible to avoid that accumulate some lateral force under the bridge. And the long-term solution is that skull protection if it's undermined by the flood, and or put that into the long-term replacement program. Why I say make the bigger fund for replacement, because that replacement is not only governed by one factor like a flood impact. It's also come from other, for example, so ongoing maintenance compared with your full replacement cost, which one is cheaper? So such kind of things need to be think about, and also replace that bridge. So will that lift the traffic service, and is that comparable to your the benefit? Is that comparable to your investment? Such kind of thinking, we will need to expand from bridge to the wider network. That's the reason sometimes, we also got some complaint from the local people. They approach Auckland Transport, okay, you got some problem on this structure, why don't you do this? Normally at that point, we will explain back, say, okay, this bridge for the wider connection reason, it didn't win the priority against others because we have limited budget to look at the whole network. So we need to make sure that left line service got guaranteed, and post-disaster recovery route need to be functional. Make sure that fire truck, ambulance can pass quickly and reach to the local area. So whole lot of those factors will driven the bridge replacement program, but replace that to what kind of level, that's really subject to the set specification, set specified conditions. And to wrap up my talking here, I put a full bulletin points here. So it's and also on the right side, that's zoomed in the bridge distribution from the Auckland whole region. You can see how many bridges and in that specific area. Just give you a big picture of the scale of bridges we are managing. So we'll try to encourage everyone to think about it and give us feedback as well, because this is not the we're not the only team to look after those. We need to get support from everyone. So one is that bridges like we have touched, it's not isolated. So we have to think about that holistically with the wider road network, traffic demand, and the future development. And bridge post-disaster parameter is sensible to environment. Yeah, it's hard to predict. We only get some lessons learned for example, those clusters, only when the flood happened. We will know, okay, this is a location, very sensible. If before that flood even you ask me, which area could be, what kind of bridge could be submerged very frequently? It's so hard because that flood water it's not only from the existing water stream. It comes down from the mountain as well, from the high point to the lower point. It's so hard to predict. But we have some lessons learned, for example, those cluster of submerged bridges. Next time, when extreme event happen, we will know, okay, this is the place our inspector need to inspect firstly. The third one will be how robust is robust enough. We need to think about the balance between the cost, or we say investment, and the benefit. The fourth is that initial investment versus the whole of life investment. Sometimes we got a cheap solution, but from whole of life management perspective, we spend more money after that. So that money also comes from everyone. So you got the number from the first 4 pages. So depreciation of the bridges at the million level every day. Next one is the investment optimization. That's cost benefit analysis we have touched. And climate change adaptation. Better chance of the structure renewal or replacement. Yeah, we should think about it. We have already, but not too much room for the existing structures, to be honest. For the new structure, like a new bridge, when you think about what's the clearance underneath, so what's the kind of freeboard we need to think about. You have your flood level. You probably can, if it's coastal area, you think about, okay, because of climate change, we need to add another meter or 2 meters. But in the existing structure, because that's confined and connected, so there's more, so it's much more difficult to make some progress, or make some space on that area. But we will think about it, and hopefully we can get more lessons learned after a while. We pack up all the work. We can flashback and carry out some lessons learned workshop and summarize what we learned from this event. And the last one is risk-based approach, preventive methodology, and the post-disaster risk management. So we have got some invaluable experience from this process. So hopefully, if unfortunately we have another event, so we could move faster and respond better than this one. But anyway, there's always space to make improvement. Cool. The last but not least, I want to speak by put another head on. I also work in the Engineering New Zealand Auckland branch, and also volunteer to be the practice area assessor for structure area chartership. So I will encourage you to look at the Engineering New Zealand website. We have a wonderful and interesting event coming in the coming financial year. That's kind of like a payback from Engineering New Zealand to the wider industry, because that's kind of like a budget come from your annual fee and give it back to the society, create an opportunity for people to connect to each other. Hopefully, we will see family fees from other events. Yeah, for those young engineers, if we meet from some chartership assessment, yeah, so make sure you be familiar with 80 standard. Otherwise, I will cast hard question. Yeah, that's all from me. Thank you very much.
Okay, well, thanks Gang and Cam for insight into AT, and David as well. I think the word of the day is resilience, robustness, and I think as Cam put it, disaster porn. Mike's a bit of that. We've got a little bit of time, so if there's any burning questions, yeah, feel free to raise your hand. And we'll come around with a mic. Yep, one over there. Hang on.
It's for the online people.
Yeah.
All right, cool. So yeah, just really in terms of protective coatings, actually for yourself, I've done a little bit of work with protective coatings and steel work, and I was curious to really understand what your approach is in terms of applying that in a manner which would suit ITPs and things like that. So from my understanding, you're going to be doing works at night time when the dew point and surface temps are unfavorable. What's your approach for doing protective coatings to your steel work? Do you build enclosures and then put in big dehumidifying units to get the limits down on things, or?
So I guess on the project that we were looking at, Hillcrest, we were really lucky that because of the way we were able to install traffic management to the site, there was quite a lot, and the piers were all not over the road. We were actually able to do it during the day, so that one wasn't done during night works. A lot of the coating replacements that we're undertaking are just like a galvanic spray that we're applying, so that also doesn't tend to be as problematic. But yeah, for that one, because we were doing it to the PCCP standard, we did have to get all of the testing undertaken. We had an independent verifier there, but it was undertaken during the day, but we had to do it. So that project we did just following Christmas, so it was during the hotter temperatures, and the way that we planned it was that we had the northbound closures in place. No, what did we did southbound first. So when everyone was going on holiday, we had the southbound closed. And then when everyone was coming back, we did it, we had the northbound closed. So that in theory, we tried not to cause too much of a problem, but it was because we had steel barriers in. So yeah, it wasn't as much of a problem. That was a fluoropolymer. That was a Dulux, and it was hot lips, which was my favorite thing about the color of that project. I've got a feeling it was, can't think now, T80 or no, but it was a fluoropolymer. So I'm told it's the way it's described to me is it's the Rolls-Royce of paint systems.
All coating suppliers will say that.
Yeah, I'm sure. Yeah. But it's I think that project it was in excess of 200,000, that painting. So it was a high cost, but a lot of it was in terms of the time to do it.
Awesome, thank you. And one last question was, when you come to assess the assets in terms of their end of life use, how many of them were you able to extend versus ones that you had to abandon, and was that in line with what you expected?
So, I mean, since I've been the asset manager, we've only, Strandrail is the first one that's come to, I'm quite lucky. So the Auckland network average age is 35 years. So comparatively to a lot of the regions, I don't have to consider that as much of a problem. Strandrail's at 97 years, but it's got a huge amount of other problems with it. It's steel beams that have been encapsulated within concrete, but they're reinforced, like there's no reinforcement under the steel beams. They put a mesh in it, and the mesh is just corroded crazily. And there was a point where we went out and did a PI on it, and we had to get an emergency closure in. And Kiwi Rail, to be honest, like I have a lot of problems with the way that we interact with Kiwi Rail, but they were fantastic. We got the closure in, and we pulled off a huge amount of concrete that if it had fallen off during normal operation would have taken out a lot of the metro network for an extended period of time. So so that bridge had problems as well as being end of life. We are working at ensuring that just because it's 100 years, it doesn't mean that we have to curtail the life of that bridge at that point. So we are looking at where we can do strengthening. I think, as I said, the Auckland network, a lot of our old bridges got taken out. The only other one that I've taken down was the old Mangrove Bridge, if you remember it. It's now being replaced with the new suspension. I say suspension bridge, it's a cable stay bridge. And that one, again, was more condition reasons, even though it had extended past its expected life. But yeah, so we are, I know there's a big push towards it. It's not as much of a focus for me at the moment because I'm lucky not to have that many old bridges, but there are a couple that will come up in the next decade. So we have, when we've been looking at like our forward plan for the next 30 years, there are a few where we are debating whether they be replaced or whether there's additional strengthening or works that need to be undertaken.
Thanks. I think it will be another question for you, David. Now we're talking about design life of bridges, and I just see this nice picture of the Harbour Bridge. I know Harbour Bridge will reach its like 100 years in the next 30 years. Do you have any thoughts of what's going to happen to that? Do you feel that the maintenance work you're doing right now will extend the Harbour Bridge design life or life of the bridge to another 100 years, or you think there are other plans for it?
I mean, unfortunately, of all of the bridges on the entire network, the only one on the motorway network I don't look after is the Auckland Harbour Bridge. So there's a, so there we've got a team of people, and it's Mike's in the room, isn't he? Mike's in the room. Mike could probably be able to answer that question better than me. But I mean, in terms of obviously the additional Waitemata Harbour crossings going in, there's a lot of constant work that's been undertaken in terms of trying to keep that bridge going, and we're re-welding of a lot of cracks and gusset plate replacements and bearing replacements. So we're doing a lot of works on it. But I mean, 30 years, that feels like a stretch to me. I don't know what yay or nay, Mike. What, 30 years? It's a struggle, you'll get there. But I mean, to me, the additional Waitara harbour crossing goes in, and then I think considerations will have to be as to what's the future use of that? Are we going to turn some of those sections into pedestrian only, a cycle route perhaps? And then in theory could extend the life in that way. It's a very well maintained structure, but it's got its problems, I guess. So yeah, maybe Mike can deliver a presentation on Auckland Harbour Bridge next time. Thank you.
Oh, one from Will.
So great presentations, Dave Gang. A lot of similar issues, a lot of concerns that keep you up at night. Clearly, I can see. Do you think there's a way of working together and sharing knowledge? And if you do that, how do you see that happening?
I mean, for me, I do keep in contact with Cam and Gang. I send them emails quite often saying, "Oh, we've seen this problem's going on, so this is happening here. And is that your bridge? Is that my bridge?" I think we we did go out and replace a joint on Hillcrest Bridge at Akaranga Station, and that's definitely one where there's a bit of a contention between the two of us as to who actually owns that bridge. But we did do a joint replacement on it. But I don't know. I think that, interestingly, I interact a lot more with like the paving team and other teams within Auckland Transport than I do with the structures team, because they're quite a discrete asset in different locations. There's not as much overlap. We're trying to work a lot more hand in hand with Kiwi Rail, for example. So they have some bridges that get strikes, and we're looking at whether the team that we use, so myself and Gareth, whether we can be part of their team in terms of keeping their network operational. So we had quite a long conversation with Lee and Coleman about our incident management process and how we can integrate with them. But do you know anything else from you?
Yeah, so I'll just might be worth to explain a little more is on the bridge ownership stuff. If you look at the bridges in the City Highway, that's definitely Dave's area. Yeah, if you say the bridge across the highway structurally maintained by David, not by Auckland Transport, even that Auckland local road network running on top, structurally maintained by ASN, and Auckland Transport will look after only the surface embraced by the external barrier. If you say the bridge across the rail track, and that's serving the local road network other than the state highway, that's Auckland Transport structure. If you say the bridge carry the rail track, that's Kiwi Rail Bridge. Yeah. So yeah, normally that's the split, the responsibility split to look after those. Ultimately, those money kind of come from the same port if you trace up. And Auckland local road network got half of the budget come from NZTA, Waka Kotahi, and another half from local government and operational revenue from Auckland Transport operation. So that's a bit kind of background information might be useful. And if you say some problem on bridges, don't think about it. Ask David first, then come to me.
Thanks both. If there's any more burning questions, particularly tricky ones for Gang, make sure you get him on the way out before his next drink, or after, depending on the answer you want to get.
Almost fall asleep.
All right. Thanks, David.
Thank you.
Gang,
Cheers.
and thanks, Cam. I think you have to take off.
Oh yeah, yeah.
All right. No problem. Okay. All right. Well, yeah, thank you. We'll wrap it up there. I'll put out another plug for Auckland Bridge Group. If anyone's got any presentation ideas or anything they want to talk about, get in touch with any of us. Names were up on the screen. It's a fair way back, but there's a few of us around. But yeah, thanks particularly to our presenters, Gang, Cam and David, and thank you all for turning up. It's good to see such a good turnout today. Cheers.